I welcome you all to the session of engine system and performance, and today we shall discuss about recent trends of technologies essentially to have better performance of internal combustion engines and to reduce pollution. So, in this context, let us discuss a few things or a few aspects towards improvisation of internal combustion engines efficiency with reduced emission. As such, the future of internal combustion engines lies in efficiency improvements, emission reduction and hybrid integration. So, these three things are very important, and to achieve all these three things, what are the technological advancement, what are the several aspects of internal combustion engines to be considered by the designer from the perspective of both fundamental considerations and applications. So, if we just write three things or three coupled keywords, as I said that the future. So, future of internal combustion engines. So, essentially if we look at the technological advancement, technological upliftment required to improvise hardware of internal combustion engines and also several other aspects to achieve number one efficiency improvements, and number two is emission reduction, number three is hybrid integration. So, we need to enhance efficiency at a reduced emission, and if we need to do so, rather if we need to achieve this, internal combustion engines should be hybridized. So, that part I will discuss later. So, let us discuss now all these points, that is efficiency improvements, emission reduction and hybrid integration. You all know by this time electrical vehicles are on rise, but still internal combustion engines will continue evolving to meet the demand or energy demand and emission guidelines, and there are certain applications wherein internal combustion engines play a crucial or other vital role. So, now let us discuss these 3 points. If we need to achieve efficiency improvements, do we need to modify hardware of the engines, or what are the several aspects to be considered by a designer essentially to achieve efficiency improvements? Let us now discuss these aspects. So, what we know that efficiency can be improved. So, I am talking about efficiency. So, this can be improvised or can be improved with the use of alternative fuels. So, I am writing alternative fuels or use of alternative fuels. So, here you can see that efficiency, we all know we need to supply fuel. So, we have discussed several times in the fuel itself chemical energy remains stored. So, that energy is converted to thermal energy in the form of heat inside the engine cylinder, and that thermal energy is converted to mechanical energy, and that is available at the output shaft of the engine. So, this energy conversion, if we try to recall, chemical to thermal, thermal to mechanical. Thermal energy is always low grade energy, while work or mechanical energy is high grade energy. Certainly, efficiency of engine cannot be increased beyond certain percentage, and if we need to think about or look for efficiency improvements, certainly an avenue could be to explore alternative fuels, and that is the one aspect, and for that what we need to do? We need to think about biofuels, then hydrogen, then synthetic fuel. This can essentially enhance efficiency, but also can reduce emission. So, these fuels can reduce carbon emissions while using the same infrastructure, okay, or existing. Okay. So, this is the part, that means instead of hydrocarbons, if we look for alternative fuels, then efficiency can be improvised, that means output at the cost of input energy can be improvised, and not only that, these fuels that we have listed down can also reduce carbon emission while using existing or the same infrastructure. So, this is one. Number 2 is advances like turbocharging, we have discussed in detail, then compactness or downsizing of the engine. So, we can integrate turbocharger or turbocharging unit, that we have discussed in greater detail, particularly in this course. You also have studied in your undergraduate internal combustion engine course. Downsizing, we all know that turbocharging means essentially you are trying to recover waste heat, rather energy, which will otherwise be lost into the ambience. So, if we can recover that energy and if we can rotate one small turbine using the enthalpy of the exhaust gases, and the turbine can be connected to a small compressor to pressurize the intake air, so that volumetric efficiency can be improvised. Not only that, that can also make the combustion efficient, right, because if we can control the temperature and pressure of the intake air, then combustion efficiency can be increased. Downsizing means we need to have very compact engine. Earlier previous engines, if you have read your undergraduate IC engine course, you will find that earlier in particular SI engines used to be fabricated by cast iron and other heavy metals, and we all know that diesel engines or compression ignition engines are bulky, and these engines have very heavy rotational rotating parts. But nowadays with the advent of material science research, it is possible to consider lightweight material like cast steel, so that engine can be engine weight can be reduced, and also we can compact the engine, and this downsizing may enhance engine performance. So, this is all about downsizing, and then it is also important to consider variable compression ratio engines. And this is known as VCR. So, variable compression engines enhance efficiency without compromising performance. So, these advancements, if I write here, these advancement enhances efficiency without compromising performance, right. So, this is all about engine efficiency. Let me discuss if there is any other aspect to be considered to enhance or improvise the efficiency. As of now, we have talked about the use of alternative fuels, advancement or advances like use of turbocharging unit, design of variable compression ratio engines, and most importantly downsizing, that is the use of lightweight material, the compactness also will lead to enhancement of engine efficiency. Okay. So, if we go to the next slide, there is another one fundamental aspect should be considered for future development of engines, that is, can I look into the alteration of fundamental or the cycle. Typically, we all know, we all have studied Otto cycle, diesel cycle, all these air standard cycles which are used to compare the performance of internal combustion engines. Now, the question is it really possible to fundamentally change the cycle so that engine efficiency can be improvised? There are a few cycles already, but I should say all these cycles are still now in the research level, but their application in rather their utilization or employment in real life applications has not been started yet. So, alteration of cycle, which is again very fundamental, can be think about or can be used to, can be taken as research endeavor to explore the possibility of enhancement of engine efficiency. So, I am writing here just that if we go to the previous slide. So, this is point number 3, that is fundamental aspect, that is cycle used to map and compare the processes of IC engines. So, I should write exploration of new cycles used to map and compare the processes of internal combustion engines. So, that way we also can look for new or new advancement of the design or development of internal combustion engine. Then most importantly, as I said you that, so these are fundamental aspects again. So, if I write point number 4, so this is again fundamental aspect, that is the advancement of combustion techniques. So, if I write here just advancements or advancement of combustion techniques. So, this is very important, and this part is there already, and advancement of combustion technique, then as I said you before, use of composite materials, lightweight materials like cast steel, aluminum, all these are already there in practice, essentially for the enhancement of internal combustion engines efficiency. So, to this end, let me tell you one thing, advancement of combustion engines that includes homogeneous charge compression ignition. So, number 1 is homogeneous charge compression ignition. This is known as HCCI. This together with reactivity control compression ignition. Reactivity control compression ignition. In short RCCI. So, these two techniques not only improve fuel efficiency or engine efficiency, but also reduce NOx emission. So, if I write here just for the sake of completeness, that is these two techniques improve fuel efficiency, I should say, and reduce NOx emission. Reduce NOx emissions. So, let me complete this part. So, this is okay. So, these are several avenues to be considered or to be looked into essentially for the improvement of engine efficiency. So, now let us come to another point that so this part is over. Future aspect of internal combustion engine, the other future advancement of internal combustion engine. One aspect is to look into the efficiency improvements that we have discussed. Next is emission reduction. So, now let us discuss this particular point. So, emission reduction, because we all know that certainly if we need to look for enhancement of engine efficiency, that would be good practice, but this should be achieved without compromising the emission level or environmental regulation to the extent possible. That means, designers should consider aspects to improvise or increase engine efficiency, but in parallel designers should also look into this important aspect in tandem. That means, we or anyone designing engine should not go for efficiency enhancement with a compromised or compromising the emission reduction or emission level. So, that means, this is very important that emission level. So, as I said you that first of all use of biofuels, that already I told that this biofuel, these biofuels can reduce emission. Number 2 is that is combustion control. This means that combustion should be such that fuel economy can be achieved, at the same time NOx emission can be reduced. So, this part is also important, and there are many things available. One such avenue could be, as I said you that if we use catalytic converter, that you all know, then if we nowadays the most important part should be the integration of electronic control unit, because if we can reduce manual intervention to the extent possible, efficiency can be improvised. In this context, let me tell you one thing. We have talked about one particular sensor, and that sensor is responsible to measure the concentration of oxygen in the exhaust gases. So, nowadays it is really possible to control everything with the help of engine management system or engine control unit, so as to regulate the emission level to meet the environmental guidelines or regulations. So, these aspects should be taken into account while designing. So, just I want to include that integration of electronic control unit. So, this unit is responsible to control the combustion. This unit is responsible to monitor the NOx level in the exhaust gases. This unit is responsible to provide adequate amount of fuel air mixture to the engine cylinder, so as to bring or ensure better fuel economy. So, this is one thing. Now, let me tell you one important point, that is the hybrid integration. So, let me write here. So, this is hybrid integration. What does it mean? Hybridization is needed. That means internal combustion engines can work alongside electric motor. Internal combustion engines work alongside in electric motor. If we can have this arrangement, plays crucial role in reducing fuel consumption. If the fuel consumption can be minimized, automatically emission level can be controlled, right. So, to this end, we all know by this time electrical vehicles have promising potential. Now, the question is uh, internal combustion engines, IC engines are considered to be point sources of environmental pollution, because in the road if we have 10 cars, so 10 different sources of environmental pollution. So, this is known as point source, rather distributed source. So, in a city if there are 1000 cars, 1000 different or 1000 distributed sources of pollution. So, from that point of view, certainly hybridization, that is nothing but the integration of electric motor with the internal combustion engines, can reduce emission together with enhanced efficiency. But the question is that, as I said you, there are certain applications wherein internal combustion engines are very much necessary even with the advent of electrical vehicles. So, what are those places? Even for heavy vehicles, then aviation, and there are even areas wherein it is very difficult to have electrical vehicles, or electrical vehicles cannot reach in those places. So, there are certain applications, there are certain areas wherein still internal combustion engines play a crucial role. So, even if we need to use internal combustion engines for those applications, perhaps hybridization could be an alternative, and hybridization can have even a promising potential to increase efficiency together with reduced emission level. Okay. So, this is all about the future of internal combustion engines. Now, having all said and done, as I said you, just I would like to write one lines that looking ahead, IC engines will likely remain essential in aviation, heavy transport, and remote areas where EVs are less feasible, where EVs, electrical vehicles, are less feasible. So, I would like to write this, because we have discussed about several aspects to be considered essentially to increase engine efficiency, to reduce fuel emission, and the concept of electrical vehicles are there in practical applications, but still there is a need of internal combustion engine in places where electrical vehicles are not feasible. That too, there are sectors like aviation and also applications like heavy transportations. In all these areas, internal combustion engine still have promising potential. So, considering this, several aspects that we have discussed in today's class should be taken into account initially at a research level, certainly then that should be implemented in practical applications. So, as I said you that fundamentally if we really can look for alternative cycles, if we can replace Otto cycle, if we can replace diesel cycle, if we can replace dual cycle, and then fundamentally if we can have better cycle to improvise thermal efficiency, then that could be a breakthrough. In this context, let me tell you one thing, probably you all know about Rankine cycle. So, there is some advancement of this cycle, and that cycle is known as Kalina cycle, and in this cycle two components are used, water and ammonia. So, though this cycle is still in research level, but maybe after a few years down the line Rankine cycle can be replaced by this cycle, and that would be a really breakthrough to improvise the efficiency of Rankine cycle that you all studied, that cycle is used to compare the performance of steam power plant. So, similarly, if there is a breakthrough in terms of fundamental fundamentals of internal combustion engines, that is the alteration of a cycle itself, alteration of the cycles itself, then it can really enhance efficiency of the engine, and that could be the most important point or a most important future trend of the internal combustion engines. Okay. So, now what we have discussed about electrical vehicles. So, nowadays the motto is to know more about electrical vehicles, and then we all are thinking perhaps in electrical vehicles will replace internal combustion engines, but that is not true, and it will not happen even, because as I said you, there are many applications wherein EVs are not suitable at all, EVs are not feasible, and that too let us discuss now maybe a few minutes to see electrical vehicles, though they can be considered as a replacement of internal combustion engines, but though electrical vehicles can reduce tailpipe emissions, but the long term, or if we look at much deeper into this particular engine, then we will see that emission level should be there with this particular type of concept, and that emission is also very detrimental and should be accounted for. So, if we write here electrical vehicles, that is EVs, EVs. Okay. As I said you that internal combustion engines are considered as distributed source of pollution, because if we have more number of IC engines or vehicles, we will be having more number of pollution sources. So, the question is, electrical vehicles really can reduce emission at tailpipe emission. So, just for the timing I am writing. So, this can reduce tailpipe emission, but these electrical vehicles, they have several, this particular vehicle or electrical vehicles have several drawbacks, rather I should say environmental drawbacks, and those are related to battery production and disposal of batteries. So, we all know that electrical vehicle efficiency should be higher, there is no doubt about it, because electrical energy is always high grade energy. What do we do with rather in an IC engine is that we supply fuel, and the chemical energy is converted to thermal energy, and that thermal energy is converted to mechanical energy. But in electrical vehicles, we need to supply electrical energy, essentially electrical energy would be converted to mechanical energy or work output. Since electrical energy is high grade energy, certainly efficiency will be more, there is no doubt, but the issue is having ensured more efficiency with these vehicles, there are severe or several environmental drawbacks, and those drawbacks are associated with the source of electricity that will be there in electrical vehicles. So, batteries are used, and most importantly these batteries are lithium ion batteries. So, battery production together with disposal of batteries are very problematic, and these aspects should be again taken into consideration for future design of electrical vehicles and the use of rather extensive use of electrical vehicles. So, they have several environmental drawbacks, particularly due to battery production and disposal. So, this is very important. Now, let me tell you one thing, batteries are lithium ion batteries, and these batteries require lithium, cobalt, nickel, and all these are extracted from extensive mines. Now, if we need to extract, or if we need electrical vehicles, rather electrical vehicles, if we think that electrical vehicles maybe a few years down the line will replace internal combustion engines, certainly there will be a need of extensive production of lithium ion batteries, and for that lithium together with nickel, cobalt should be extracted from extensive mines, and this extraction process again will be associated with degradation of soil, environmental pollution, water contamination, all these things. So, if we think about, then we can see that electrical vehicles, though they can reduce tailpipe emission, they can eliminate or they can reduce or they can suppress distributed source of pollution, but still there is a possibility of having pollution or environmental pollution, and those are associated with battery production, and that we have understood. So, if we write in the next slide just for your completeness that environmental pollution associated with battery production. Battery production, because this battery requires lithium, cobalt and nickel. So, chemical formula I am writing LiCON. So, all these materials are extracted certainly from mines, and these materials are extracted through energy intensive mining. What does it mean? That means extraction process itself requires extensive amount of energy. So, otherwise it is very difficult to extract all this material, and you know that if we need to extract all this from the mines, certainly rather if we need to have extensive production of lithium ion battery, we need ample amount of lithium to be extracted from the mines, and the extraction process as I said you. So, this process, if I write here this process, so extraction process leads to deforestation soil degradation and water contamination. So, we can understand that essentially if the objective is to reduce emission, of course, efficiency can be increased as I said you, because electrical energy is high grade energy, but to achieve better efficiency, though we can really suppress distributed source of emission by using electrical vehicles, but electrical vehicles are associated with the extensive use of lithium ion batteries. To produce lithium ion batteries, we need materials like lithium, cobalt, nickel, and extraction of all these materials from minings are associated with deforestation, soil degradation and water contamination, and all these are associated with environmental pollution. So, that means designing or having electrical vehicles, though we can really suppress distributed source of pollution, but we are still trying to enhance pollution or environmental pollution from the perspective of this extraction process of materials. Okay. Now, let me tell you one thing, but this is about production, and then what is disposal. So, battery disposal, right. So, any battery that cannot be used for a long time, because battery will be having certain lifetime. Now, if we need to dispose that batteries, rather unused when the battery will not be or rather cannot be used. So, those batteries disposal is again very problematic, because degradation of lithium ion battery is a long term process. So, if I write here a few points that will help you. So, as I said you that lithium ion battery, lithium ion batteries or degrades over time and requires proper disposal. That means we cannot dispose lithium ion battery arbitrarily, because we need proper disposal, and if the infrastructure is insufficient, then this disposal process leads to water and soil pollution, from toxic chemicals. Okay. So, that means what you can see, that production of lithium ion battery is also associated to the environmental pollutions, because extraction of all these materials needs energy intensive mining. Then these materials, if we need to extract, it will be associated with deforestation, soil degradation and water contamination. Then we can see finally, even if we can produce lithium ion battery, then we need proper disposal, because lithium ion battery degrades over time, and the disposal process requires sufficient infrastructural development. If the infrastructure is insufficient, then this disposal process will lead to the soil and water pollution from the toxic chemicals. This is one thing. So, that means what we can understand, though electrical vehicles are efficient more than the internal combustion engines, and also electrical vehicles really can suppress distributed source of pollution, but if we look at carefully, we can see electrical vehicles are also associated with environmental drawbacks, and those are associated with battery production and battery disposal. So, challenges are there to have proper infrastructure for the disposal of lithium ion batteries, and also when the requirement will be very high, then we need to produce extensive amount of batteries, and which will in essence be associated with environmental pollution that we have discussed. So, to summarize our today's class, we can say that we have talked about future of internal combustion engines, what are the several aspects to be considered by a designer to improvise engine efficiency, to reduce emission, and certainly hybridization of the internal combustion engine. Then we have discussed about electrical vehicles, because electrical vehicles, as I said, you all have studied by this time, or you all know by this time that electrical vehicles can replace internal combustion engines, but there are some issues, rather challenging issues to be considered before this rather electrical vehicles can really replace internal combustion engines. Finally, what I said that there are certain areas, there are certain applications wherein still internal combustion engines play a crucial role. So, I stop here today, and this is the last class of this course, and I hope you all have enjoyed learning several modules of this course, and I believe the remaining modules you will enjoy. And if you have any questions, if you have any doubts, please feel free to email me. I shall be happy to give answer to those queries. Thank you very much.